Hello, my name is Angel, and today I'm here with my teammate, Rafael.
Glad to be here.
To talk to you about how to develop serverless applications with Wasm Workers Server. Just before starting with the topic, a bit introduction about what we are doing. So we are both are part of the team called Wasm Labs at VMware, and the idea is that we explore, create, and contribute to projects to showcase the possibilities of WebAssembly and also helping developers to adopt this amazing technology. And now, let's talk just a little bit about serverless and WebAssembly. So serverless is a popular cloud computing model that has been using for several years already. So the main idea is that it abstracts developers from the underlying infrastructure. So your service, instead of building microservices or an entire application, you build small individual units that are in charge of replying to specific events and provide a response. So these individual units are usually called functions or workers. The main difference between these two terms is that initially, all the platforms talk about functions, as it's the easiest way to define those. But recently, some companies like Cloudflare are starting to introduce the concept of workers, which is a similar concept of functions, but they took the ideas from the web platform APIs and integrated into this, the serverless model. So the idea is that you get requests, you process them, and provide a response to your users. If we think of an application, kind of a microservice or application, we have the framework that we are using, regardless of the language. We have the libraries that specific framework depends on. You may have more things that your code needs actually, and then your code, which is the thing that you are actually coding. The idea for serverless is that we take that code and split them into individual units that will be the ones implementing your business logic. If we focus now from the point of view of developers working with serverless applications, you may want two main things. First thing is that you want to focus on writing the code or writing those functions or workers that will implement your business logic. And then, ideally, you want to reuse all the knowledge that you already have to develop these workers. We really think that WebAssembly is a game changer for this ecosystem. And this is because, from the developer's point of view, it gives you the ability to write your workers and functions using almost any language. As you can, for example, target WebAssembly from compilation. You can use interpreters inside that are already compiled. So that makes WebAssembly a great idea for running serverless. Also, thinking now a bit more about the future, the component model will even go a step farther in that direction, because developers not only will be able to reuse the existing knowledge in terms of languages and libraries, but also small components that the community and even your company will be providing to you. So you have already efficient libraries compiling to WebAssembly that you can reuse in any project or any worker. But let's be fair. It's true that when you get started, it's a bit of a complex ecosystem. So I can speak by myself. I've been working as a full-stack developer for several years. And 1 year ago, I started working more specifically in WebAssembly. So the first thing that I did, of course, was to look about what's WebAssembly, just to get a bit of information about this technology. WebAssembly itself introduces a new set of concepts and tooling. So for example, you need to think now what's an ISA. You have also that it's a stack-based virtual machine, which are terms that you are not used to when you work as a full stack or you are working just in services or microservices. You also need to think about compilation. Is that the way I'm going to work always with WebAssembly? Do I need now to learn a new language? How I pass the data? What's even the host and the guest? How can we pass that? We were talking in previous presentations about that. And also the differences between browser, server, what's WASI, how it helps me to build the solutions I need. It's kind of complex. So at that time, when we were researching about this, we thought, like, is there any way we can take all the benefits from WebAssembly and, for now, ignore the complexity and all the new concepts? And this is why we created this project. So the idea behind this project is that we want developers to be productive quickly while creating the apps that fully benefit from WebAssembly itself. And that's Wasm Workers Server, or the implementation of this idea from the Wasm Labs team. So Wasm Workers Server is an open-source project for developing and running serverless apps on top of WebAssembly. So it exposes all the workers that you write as an HTTP API, receiving requests, and then returning the responses to your users. The same way that we were talking before about these individual units, thanks to WebAssembly, now you can write those workers in different languages. You can use JavaScript, you can use Ruby, you can use Python, and in the future you will be able to use more as we add more and more support for new languages on this project. And one of the questions that you may think at this point is that, but how quickly can you get something work with Wasm Workers Server? So for that, I'm going to give the turn to Rafael.
Yeah, so let's see how that... OK, so what we claim is that you can do this in less than 5 minutes, and we are going to reproduce that. So let me just run that. And the idea is that you are going to be able to install Wasm Workers Server and run an example function in less than 5 minutes. Well, this really depends on the download speed that we have here, but this is kind of the idea. Let's wait for it. And now that we downloaded it, we just installed it locally, like in the local directory. We can actually run the help command that is going to tell us what is disabled to do. And here, this is a work in progress. This project just started, let's say. We have the runtimes command that Angel is going to talk a bit about later. And you are just able to provide a path where you have your workers, and they might be in different languages. And you can configure other things, like what is the host, the port, and the prefix. And I have created a directory called my workers that you can see over here. I only have one worker, which is written in JavaScript, and it's called GSBasic. So my service is called GSBasic, or this function. And so the code is really straightforward. If we go to the end, here we see that we are using the fetch listener, and then we respond with our own Lambda, where we reject everything that is not a GET request, and then we answer with definitely a tpod body with a 418 HTTP code. So we can just run Wasm Workers Server with it, and it out of the box detected that the folder is GSBasic, and it exposed that on this specific path. And so now you can see that we have the detected root, which is being served at 8080/GSBasic out of the box, without me having to configure anything. So if I go to this one, you see that we got the expected response, definitely a tpod, and a tpod 418 is the return code. So you can check the documentation at workers.wasmlabs.dev. There is more information out there. And there is also a really nice thing here that you can reuse this work in other platforms. And this is no coincidence because of the decisions we have taken in order to make it this reusable, for example, with other projects, as we are seeing here with Cloudflare Workers. And so if we look at the command or the code from this worker, it's basically the very same thing. I just copied and pasted the code over there, and I can just run Wrangler over there, and it's going to start. It's starting. And now I can just go ahead and curl over there. And you see it's basically the same answer that we got from before. So yeah, and Angel is going to explain more about how it works.
Yeah. So thank you for the demo. So basically, you saw like in 5 minutes, in less than 5 minutes, you can have already a worker running. And not only that, but you can also use the same code to run it in different platforms. So before going a bit more on a more complete demo about what applications can you run with Wasm Workers Server, let's talk a little bit about how this works and what are the decisions that we took to create this project. So when you start a Wasm Workers Server process, it will check all the different files that are in the folder that you passed to the CLI. It will identify what are the files that can be managed or can be converted into workers, and then it will, based on directly on the name of the files, it will serve an HTTP endpoint. You don't need to configure anything. It's just everything based on the file system, which is called, for other projects like Next.js, they call it file system routing. For certain source code, like you can see here for JavaScript and for Ruby files, you cannot run them directly. So you need a specific runtime to run them, like the Ruby interpreter or a JavaScript engine. For those cases, the Wasm Workers Server detects what's the runtime that it needs to use. It downloads them as a WebAssembly module. So those are basically the Ruby interpreter compiled into WebAssembly, and the same for JavaScript. And then we'll use that to run the source code that you already created and provide responses to the users in the APIs that you can see there. Apart from that, it comes with other features that we are going to see now. So that's the basics for this project. And now the interesting part is what you can build with this project. And today, I want to show you how you can create your own Maps service API with Wasm Workers Server and ProtoMaps. So ProtoMaps is a serverless system for planet-scale apps. This is the headline that they have in their site. So what they offer are two main things. They offer basically a way of storing all the maps metadata inside one file, and then a set of libraries that you can reuse to serve that information to clients like the maps that we show in websites and in applications. I think all of us here are consumers of maps in many different ways, Google Maps, Apple Maps, and everything. So how this works internally is that you have first a client that is able to reproduce maps, and then you need an API that serves you the maps metadata. Just super basic things about maps. Maps in reality are composed by tiles. So all that information is usually distributed, and it requires you APIs like Google Maps and Apple Maps to serve you these tiles. But of course, they have a free layer. But at some point, you may want to host yourself these services. As they were saying in ProtoMaps, at 1% cost of a regular service. And this is what we did with Wasm Workers Server. Thanks to the ability to reuse the existing code and to reuse libraries, you can run ProtoMaps with Wasm Workers Server. And I'm going to show you how to do it. So here we have the sites from ProtoMaps. It contains a lot of information. If you're interested, I totally recommend you to check it. And the first thing that we need to do is to check what are the libraries that we are going to use. So the ProtoMaps team already put in place several libraries. They have JavaScript libraries and other languages. But for this specific example, we decided to use Python. So from the repository, they have tools for converting things, writing maps. That's not something that we are going to do today. So we will focus on the reader and the tile libraries. Oops, I lost. OK, now it's back. So I just took those libraries directly from the repository and put them locally in my project. So we have the tile, which is a library to read those small boxes from the map, and then the reader, which is the one loading the entire map information. For those files, tile is not modified. For reader, we had to do a slight modification how the map is read, but just minimal modifications. Then we need a map to show. Fortunately, ProtoMaps already provides you with some example maps. So I just downloaded the planet map that they provide. It's a 2.4 gigabytes file. That's the reason I put it like in advance and not have to download it here. And then let's start from the client side. So how we are going to show this. In this case, as a demo, I created an index.html file, which uses Leaflet, which is a library, JavaScript library for maps, then the proto-maps library. And here we have the integration. We have to create the map, and then we should add a new layer with the URL. So this URL is the actual API that we need to implement using workers. One of the conventions that we followed in Wasm Workers Server, as following the idea of using the file system as the way to create the applications, is that the public folder is automatically served as static assets. So anything that you put inside here, it will be served as static. That's the reason we have here the index, the JS, and the CSS. So the next step is to reproduce this specific URL in a worker. As you saw before, the URLs are composed by the name of the files. To create dynamic routes like this one, because these values will be replaced by the actual information from the map client, then we use the brackets and with an identifier inside. So that will automatically convert those URLs into dynamic routes that can retrieve the params inside the workers. Here we have the same approach, like Z, X, Y. And here we have our index.p file, which is the actual worker that will provide you with the tiles. Here, as Rafa showed before, the concept is pretty similar. We have a function that receives a request, and in the end, return a response. That's the only thing that we need to provide to create a worker in Python. So for this case, we import the libraries, we import the reader, then we load the map. At this point, we pass the map information to the reader. We got the parameters from the request. And then we try to get the point, just to get the tile. If the point is filled, let's return it. If not, let's return tile not found. And that's all we need for creating this API. Then the next thing, as you saw at this point, is that we need these libraries and maps available inside the worker. So this is the only point in which you need a specific feature when you need to create a configuration file. For creating a configuration file to configure your workers, you just need to create the same exact file name, but with a TOML extension. And then you can do things like adding environment variables, mounting folders, and other features, like an in-memory key value store, for example. So now that we have all the code ready, we need one more thing, and it's that we need that Python interpreter. Unfortunately, we cannot ship all the interpreters inside the Wasm Workers Server binary, because that will make it grow like forever, just because we are not only offering a Python or Ruby interpreter, but also several versions. So for that, we have the runtimes list command that will give you all these open source models that you can also download by yourself, the ability to directly install them inside Wasm Workers Server. You can install like runtimes, install Python latest. Oops. But I already installed it. So instead of doing that, I'm going to show you like with the check that, whoops, it's a bit, so let me remove this. So that's already installed here. So I don't need to install it again, just once. So now let's run the project, WWS. Let's use the port 9090. And automatically, it will look for the routes in the current folder. So as we saw here, it's going to serve this API and also all the static assets. So now if I go here and go to localhost 9090, we have our map, and we have our API working. So now you have your own service that you can take this and deploy it anywhere. It's a self-contained server, so you can use any machine, you can use a container, you can use the best approach that works for your use case. Okay, and now let's continue a little bit, explaining a bit more about how this project and what's the idea behind it. So the idea is that we want everyone to create their own workers and to be able to run them everywhere. and what that means for us. So the first thing is that to run it everywhere, we think that the best way to accomplish that is to ensure that we follow a set of conventions. When we were looking for those conventions, when we started this project, we found this great initiative from the teams on Cloudflare Workers and Dino, now supported by more companies like Shopify, like Vercel, Netlify, that it's called WinterCG. So the idea of WinterCG is that documenting and improving the different web platform APIs that can be reused on the server side for creating applications. So this maps the ideas from the web APIs and put them inside the other runtimes. So you have a common API that can be reused in different platforms. We took these ideas because we think those were great and were already supported. It was not a coincidence that before the same exact JavaScript code that we created for Wasm Workers Server ran in Cloudflare. And that's because we are following these conventions. It's true that there is still a long path for Wasm Workers Server to be WinterCG compatible. And that's because this documentation or this spec focuses on JavaScript runtimes, while Wasm Workers Server can work with many different languages. So the idea is that for JavaScript, we aim to target compatibility with WinterCG, but for other languages, we reuse the same ideas and concepts like requests, responses, and all of that, and put that in the language so you can reuse them with the language that you prefer. And now, talking about languages, Rafa is going to give you an introduction about how those runtimes work.
Yeah, so we have seen an example. This example used Quick.js in order to run the JavaScript code. We have seen another example with Python, but how does this work under the covers? And the answer is, in our case, we are building the Wasm language runtimes, which is an open source project that provides popular languages, their interpreters. In this case, we are providing Ruby, Python, and PHP. We have done the work to port PHP, the interpreter. We also have work to upstream that to the upstream community. And then what Wasm Workers Server is able to do is to download the right runtime from this very well-known set of the list of languages that we support and build and publish, and then it just runs the runtimes. But the idea is that this is available for the whole community, and actually there are other projects such as Spin, for example, that is also has documentation on how to run this, for example, or PHP with CGI as a server. And in that context, when we released actually Wasm Workers Server 1.0, where we had support for Python and Ruby, and we actually kind of announced that, Yukihiro Mats, who is the Ruby's daddy, he said, well, after retweeting our release, he tweeted, "I'm glad Ruby wasn't left behind this time." And we think this is really important, and this is something that we think WebAssembly can also embrace. It can also help embrace everyone in the community. And so, as Buddy said on Toy Story, no toy gets left behind. And in that context, we, as Wasm Labs, what we want to say is that no app gets left behind with WebAssembly. And this is what we want to achieve. We want to get as many developers as possible to WebAssembly, and so we can build an even bigger and greater community. And Angel is going to speak about the next steps of this project.
Yep, so after you watch this presentation, you may think, what are the next steps? So we recommend you to try it. It's as simple as just running that command. You have also a quick start guide for 5 minutes introduction. You have a lot of examples. We will publish also the proto-map example that you already saw, in case you want to host and create your own map service API. You have also our website, in which you can find other projects, all the articles, and also on Twitter. So we encourage you to try this and just give us feedback about what are the next things that we should prioritize and how we can make Wasm Workers Server better for everyone. And what's next in terms of features, or what we plan to have for this? So the first idea is that we want to support new languages. That's the entire goal, that we add more support for languages that can target WebAssembly natively, like Golang, for example, and others like PHP, as Rafa was commenting before. Apart from that, we want to provide workers with new features, such as fetch, persistence, and everything. This is kind of a challenge for Wasm Workers Server, as it not only supports JavaScript, but many different languages that requires you to create bindings and all those functions exposed to the workers. That's where we really think that the component model can help us. And we are already exploring how we can bring all those features into the different languages at the same time, thanks to the component model. So the idea is that adding more languages will take less time, as we can reuse the code between every language. Finally, I would love to say that if you are trying or playing with serverless and you want to get a better overview about what's in the ecosystem, we totally recommend you to check other amazing projects that are around. I think we already have several talks in this amazing conference with Fermion Spin, Wasm Cloud from Cosmonic, Suborbital, and also Scale SH. Also, congratulations to the Fermion team for the announcement of 1.0. And that's all from us. We want to also thank you, all the amazing community. Wasm Workers Server is based on really great projects like Wasi, Wasm Time, and much more. So thank you, because it seems that this is a really vibrant ecosystem, and we are really glad to be part of that. Thank you.
Thank you.
I think we have 5 minutes for questions.
Yeah.
You have any?
Hey, thanks for the presentation. Have you explored the component model with regards to communication between the, how shall I put them, those, let's call them processes that run inside the runtime? Let's say I have a Ruby component I want to expose to my JavaScript component, vice versa. Because this TCP/IP is slow for some, and HTTP is even slower, so the idea is that when the request does come in, maybe there's going to be some work sharing between different languages, which is the holy grail of all of us being able to use all these languages at the same time. Have you explored the possibility to do so? I mean, it's not up to you, obviously. The component specification is about to one day solve this problem.
So thank you for the question. That's actually one of the things that we would love to bring to this project. So one side, the component model, we think may help us exposing those, the features that Wasm Workers Server can provide to the different workers. So that's one part. And the other part is what you exactly mentioned, about reusing existing modules and can connect them with their workers, so you can reuse and share things. That's something that we are exploring also. We are not there yet. We are first targeting providing the features that we want from the host, which is Wasm Workers Server, to the workers. But that's definitively one thing that we want to target. The ability to, the same way that you have libraries that you can share, in this case we are mounting them inside, what if you can share modules directly and connect them to the workers to expose certain APIs? That's something that we would love to explore and that we think can bring a lot of value.
There is also something that if you put a Wasm module inside a directory, it gets served. As long as it provides the contract that Wasm Workers Server expect, it will work. For example, you can write a function in C. And so if you build a module in a way with a component model where you have everything that you need in this module, then you will be able to get advantage of the component model on your own module, and then this gets served with Wasm Workers Server without any issue. So that will be a way to use that. But yeah, definitely something we have to check.
I think there is a question there.
Yep.
OK. There.
Hi, great talk. Have you tried also other mapping techniques for the URL request parameters instead of just those bracketed folders that you have shown?
So just to understand, so the question is if there are other features around how you can build URLs with Wasm Workers Server, or?
Yeah, how to get these request parameters out of it. So how to map the request parameters. You've shown this way with the folders with the bracketed X and Y and Z. Is there other mappings, for example, in the config files, or do I have to abide to this folder structure?
So in this case, for now, the idea is that the file system is the one defining the URLs. So that's the reason why we use the brackets. You can reuse the bracket not only with folders, but you can reuse also in one file. So the file name could be brackets with the identifier. You can use also multiple identifiers in the same file name. You don't need to create, for example, if you need, I don't know, one parameter which is ID slash or dash another parameter like, I don't know, ID2. You can get both in the same file name. You don't need to go with the folder structure. That's just the way that we did for this example, just to follow that slash, and slash with parameters. But currently, there is no way to edit that in the configuration files for the workers, because that relies completely on the file system. Thank you.
Yeah. Hi. How would you describe the main struggle that everybody's having for the adoption of a component model for Wasm? What's stopping you, or not just you, but everybody involved to achieve that?
So,
I didn't get it, sorry.
Okay, sorry. Yeah. What's the struggle that you're having, or what's the struggle on an industry-wide basis for the adoption of the component model for WebAssembly? What's stopping you from implementing this?
Okay. Well, nothing is stopping us in the sense that, this is a work in progress. So right now, it's like we have to figure out how would we integrate that. But for us, as the way I see that, is that with component model, you are able to reuse pieces of software in a way that you can compose bigger programs. And so you are able to put pieces in the middle that are able to filter certain attributes, for example, when you're working with bigger components, or when you're working with the final program, let's say. And so with the component model, you will be able to serve a function that contains several other components if you provide that. And then these components will will map certain attributes or certain calls of these functions. And in the end, this is a tool for developers. So we want them to, to get used to this software and to start working with WebAssembly and get these people into WebAssembly. And so the idea is that, it will be straightforward for them to try them out, to try their software within WebAssembly. So component model is another answer to that, and we have to think about how we are going to grade that. Does that answer to any extent what you?
I mean, it looks like there's a lot of controversy as far as how that adoption is going to take place, as far as the standardization goes, et cetera. Mm-hmm. Can you speak to that?
So maybe replying specifically to that, Wasm Workers Server is also based on these modules that Rafa was talking about before, about, for example, the Ruby interpreters, Python interpreters that we are compiling. We want those to be as universal in terms of that everyone can take those modules and run them to run, for example, Python scripts or Ruby scripts and get the information there. Those modules actually are compiled in a separate project, so anyone can download them and reuse. And that's we need to. Okay, that's sorry. We need to finish. So that's one of the main reasons. Like, since we want those modules to be compatible with everyone, and the component model is not still implemented in the different runtimes, we are still sticking to not using component model. And the other reason is time, that we need also time to better understand what's the integration with Wasm Workers Server and how we can make it available while not compromising the compatibility of the builds that we are doing for other projects. So thank you. Thank you very much.
Everyone.